Okay, what we're looking at today is the Pythagorean Theorem. The Pythagorean Theorem is an important theorem inside of mathematics. It is something that you're going to see in 8th grade, you're most likely going to see in algebra, you're going to see in geometry, and you're going to see in a lot of your math classes, even beyond that. And it comes down to the idea of a squared plus b squared equals c squared. A and b are the legs of the right triangle. A and b make up that right angle. They create that little square. C is the hypotenuse of the right triangle. C is right across from that right angle. If you imagine this almost as being like an arrow, it's going to point to C. It's always going to point to that hypotenuse. And when we do a Pythagorean theorem problem, we always have to identify where C is, because C has to be in its correct place. A and B are interchangeable. So if I take a look at my first couple problems here. If I look, there's my right angle. So it's pointing here, so it's telling me C is missing. So again, the formula is a squared plus b squared equals c squared. So I can say that's a, that's b. So that becomes 3 squared plus 7 squared equals c squared. So that becomes 9 plus 49 equals c squared. I add those two together, I get 58 equals c squared. Now what I'm going to do is take the square root of both sides. So c is equal to the square root of 58. Now the square root of 58 is an irrational number, because it's a number when we put in, it never ends, it never repeats. So for some people, they want just saying, oh, the answer is the square root of 58, and you're actually done. Other times they want you to write it a few places after the decimal. So what you need to do is sort of put it into the calculator. And when I put it into the calculator, and I put the square root of 58 into the calculator, I can go 58, hit the square root key, and I get all of this. And let's say I only want 3 places behind the decimal. So I go 6, 1, 5, I look behind it, it's a 7. So I'm going to round this up, and I'm going to say that's 7.616, because I went 3 places there behind the decimal. Again, this is an approximation. It's not necessarily exact. But that really is kind of 2 possible answers. Sometimes they'll say just leave it in that radical sign. Other times they'll say to round it to 3 places after a decimal, round it to 2 places after the decimal. You have to say how many they'll tell you how many places they want behind the decimal point. So now let's take a look here at the next one. Again here, okay, this points to right there. So that's telling me again this is C. I can say that's A, that's B. Again, A and B don't matter. C does. C has to be in the right place. So I'm going to say that's 7 squared plus 2 squared equals C squared. Well, 7 squared is 7 times 7, which is 49, plus 2 squared is 2 times 2, which is 4, which becomes C squared. Well, that becomes 53 equals C squared. So C is equal to the square root of 53. Now again, if they want, let's say, 3 places behind the decimal. Again, all I do is I type in 53, I find my square root key, and I get all of this. So again, I look 3 places behind the decimal, 7.28, there's my 3rd place, which is at 0. Behind it's a 1, so I'm going to leave it alone. So I could put 7.280 or 7.28, because if it's a 0 and it's after that decimal point, I can really just drop it. And again, I should put my equal sign kind of with the squiggly lines, because it's not exact. It's close, but it's not perfect, because if I put 7.28 times 7.28, I'm not going to get 53 in my calculator. Okay, let's look at the next two examples. In these two, if I look, oh, they gave me C. So I can say that's A, that one's B. So I'm going to go 12 squared plus B squared equals 13 squared. Well, that's 144 plus B squared equals 169. 12 times 12, 13 times 13. Now what I want to do here is subtract the 144. It's like a one-step equation. B squared equals 25. Well, here when I take the square root, B is actually just 5. Because the square root of 25 is 5, because 5 times 5 does give me 25. And there I can use the equal sign because that's an exact answer. That's a perfect square. Okay, let's take a look at this last one here. Again, there's my arrow. It's pointing at C. It's telling me, oh, C is 15. I can say that's B. This is A. So I can go A squared plus 13 squared equals 15 squared. And again, once you get these in the right place, all you have to do is then do those calculations. So that becomes 169 equals 225. Subtract the 169. So when I take the 225 and subtract the 169, I get A squared equal to 56. So A is the square root of 56. And again, if I want that, I take that 56, I hit my square root key. And if I'm going 3 places behind the decimal, I got 7.48. That's 2 places. I'm looking at this third, which is a 3. I look behind it, it happens to be another 3. So I could just leave it. And it's about 7.483. And that's what you really do with that Pythagorean theorem. They're going to give you 2 of the numbers. You have to be able to find the third. And a lot of it comes from calculations and really even using a calculator, because you can do almost all of this right there on your calculator. And that helps you find the missing side for the Pythagorean theorem.